right, this is our first section of notes on gases. And you're familiar with gases as a state of matter, the one where they are far apart. Now, some important characteristics of gases. Are, of course, the gas pressure, which is collisions of the gas molecules with the walls of the container. So you have some sort of container and you have gases in there, and as they move around, they have collisions. Now, pressure is force per unit area. So, things that will affect gas pressure are the number of molecules of a gas, because more particles would give you more force. If you increase the temperature, the particles would move faster, so you would get more force. Okay, if you increase the volume, you're going to have more area. So force divided by a smaller number, you're going to have less pressure. Now we have different units of pressure. And standard pressure is defined as 760 millimeters of mercury, which is equal to 1 atmosphere, which is equal to 101.3 kilopascals. We have equalities here with our units, so we can convert. We have 0.92 atmospheres. We would set it up like that to convert to millimeters of mercury. And so we would get 699.2 millimeters of mercury, which was a pretty poor example. Let's make it 0.920. Because then I can do the significant digits. Now, with all of our gases, we treat them as if they are ideal. Okay. We treat real gases as if they are ideal. That way we can use the gas laws to predict behavior. So real gases behave like ideal gases under many conditions. What are those conditions? They are any that get the gas particles very, very spread out. So low pressure and high temperature. Boyle's law is our first law, first equation. Volume varies inversely with pressure. So volume up, pressure down. So in an inverse relationship, the product is constant. So when we do a problem, we want to show our work. And our problem-solving steps. So the first thing you want to do is make a list. And that list will contain your unknown and your given. So a balloon is filled with 25 liters. That's a volume, first one I get to. At 1 atmosphere, that's a pressure, first one I get to. What is the pressure? So P2 is my unknown. Call it X, call it question mark. When the balloon's volume has doubled. Now in this one, you can probably just logic it out. Volume double, pressure half. And that's true. But let's go through the work just because we would on something with more difficult numbers. So volume 2 is 50 liters. So the next thing you want to do problem solving wise is write your equation. Always write your equation before you put any numbers in. Now, next, okay, and the next step doesn't really matter which you do first. Okay, doesn't really matter which you do first. You can solve for the unknown, then plug in the numbers, or you can plug in the numbers, then do the math. I like to solve for the unknown, then plug in the numbers. So I need to find myself some more space. So my P1 V1 equals P2 V2. P2 is my unknown, so that's the one that I need to get by itself. So divide both sides by V2, and over here it cancels. Now I plug in my numbers. So I have 1 atmosphere times 25 liters divided by 50 liters. The liters cancel, and I get 0.5 atmospheres. And it has the correct units and the correct sig figs. All right, pause this recording and try this sample, and then play it again to see the work. So we're going to make our list. 5 liters, that's our first volume. 1 atmosphere, that's our first pressure. What is the new volume? So what, there's our question word, there's our unknown. If the pressure is increased to 2.5 atmospheres. So our equation is P1 V1 over P2 V2. Our unknown is V2. So to get it alone, we divide both sides by P2. So P2 cancels over there. We plug our values in. 1 atmosphere times 5 liters divided by 2.5 atmospheres. This is V2. So we have atmospheres on the top, atmospheres on the bottom, they cancel. We have 1 times 5 divided by 2.5. So we get 2.0 liters. And that has the correct units and sig figs.